Everyone, today in this video we will solve one problem in finite element analysis using Jacobian matrix method. So firstly we will go through the question and figure given here how to solve. Later we will know how to solve the Jacobian matrix method. So firstly what they have given, evaluate the Jacobian matrix at the local coordinates where epsilon naught equals to Poisson's ratio equals to 0.5 for the linear quadrilateral element. Okay, what they are saying, this is the linear quadrilateral element which carrying the local coordinates bolke they are saying. So these were the coordinates at 4 points. So what they are saying, how we are considering these points, this as first element which is x1 y1, x1 is 2, y1 is 2, and we are considering this is the second coordinates. In the same way this is x2 and y2. Here you can see x2 is 6 and y2 equals to 3. In the same way this is the coordinate 3 and we are writing this as x3 comma y3, and this is the coordinate 4 and we are writing this as x4 comma y4. Now what we have to calculate using Jacobian matrix, we have to find the Jacobian matrix. So the formula to find the Jacobian matrix is matrix J equals to J11, J12, J21, J22 is the formula. So by based on, now we have to calculate the J11, J12, J21, J22. By what values which we have now to calculate? We have epsilon naught and Poisson ratio is 0.5, and we know that x1, y1 up to x4, x5, y4 tak we know the values. Based on those values we have to calculate the J11, J12, J21, J22 values. So in detailed explanation and in theory textbooks, we know they will explain how these formulas has been arrived and everything. You please refer the finite element analysis textbooks for these formulas. So I'm directly taking over here. So J11 equals to, the formula is given over here, so that we have to substitute 1 by 4 into those values over here. So minus of 1 minus this is the Poisson ratio where they have given is 0.5 into x1 value we know here which is 2. Okay, in the same way x2, x3, x4 values we know, we are substituting that. In the same way Poisson ratio value is 0.5. So after substituting all those values over here, we will get J11 equals to 1.625. In the same way the formula for J12 is that 1 by 4 of this is the formula. So Poisson's ratio only we are taking over here. So the value is that 0.5 for Poisson's ratio. Okay, so after substituting all those over here, y1, y2, y3, y4 values we know here. So we are substituting all those values over here, so that we will get we are getting J12 equals to 0.875. In the same way we will calculate for J21. So the formula is that epsilon naught value is also 0.5. In the question they have given same value for Poisson's ratio and epsilon naught. So the formula is here, so that after substituting all those values over here, we know x1, x2, x3, x4 values also. So after substituting all those values over here, we will get the J21 value as 0.125. In the same way J22 equals to 1 by 4 of, this is the formula to calculate the J22 value. So after substituting epsilon naught value and y1, y2, y3, y4 values over here, we will get J22 equals to 0.875. So how we will write this matrix? Here we got J11 as 1.625 and J12 is 0.875 and J21 we got here is 0.125 and J22 here we got is 0.875. So we have written in the form of matrix. So now we are converting this is an debt in the form of debt J equals to DBCA we will write. So which is AD for debt, how we will do? AD minus BC we will do. In the same way this 1.625 into 0.875 minus 0.125 into 0.875 we have to do, so that after substituting this we will get 1.3125 the value for the Jacobian matrix. So this is the matrix of Jacobian and this is the debt J. So if you all like this video, follow, like, share and subscribe to this channel. Thank you all. And everything, please do follow my Instagram page which is CE_knowledge_world.